Today I want to talk about chapter 2. Chapter 2 talks about parts of a C++ program, the cout object, include object, how you can write a program, how you can define variables, what are literals, what are identifiers. In this example here, we have a simple C++ program. You can see that this / is a comment. So hashtag include iostream, we're including a library named iostream. Using namespace std means I want to have a namespace, which that namespace is std. And main is the name of your function. The functions, we open and close parentheses after them. Beginning of a function starts with an open brace. We have this cout hello there, return 0, and then we close it. This is a main function. The main function starts with this int. This means this function returns an integer data type. You can see here in the return statement, we say return 0. That 0 is an integer data type. So the comments in C++, they start with // Hashtag include iostream is what we call a preprocessor directive, which you're including a library named input output string. By saying using namespace std, you're including a namespace, which that namespace is std. I'll talk more about this namespace and what they are. When you have a function, after the function, we open and close parentheses, we define the function. We have some special characters in C++ like // which you can begin a comment with that. You have the £, which begins preprocessor directive. We have open and close brackets, which it can use to include the library names. It goes around the library name. We have open and close parentheses, which is usually when you name a function. We have open and close braces that enclose a group of statements. We have double quotations that are used for strings. Semicolon indicates end of a statement. C++ is case sensitive. Uppercase and lowercase characters are different. For example, main and main, there are two different things. This M is capital. This M is small letter. When you want to define different variables, you have to remember that the C++ is a case-sensitive language. Every time you open a brace, you must have a corresponding closing brace. When you want to display something on the screen, we use the cout statement. The cout usually goes with double left arrow. In this example, I'm displaying hello there. I say cout double left arrow hello there in double quotations. Semicolon indicates the end of the statement. Whenever you want to display a string in C++, we put that string inside double quotations. You can also display several strings using cout statement. In this example, I say cout double left arrow hello, double left arrow there. I have two different strings that I'm separating them with double left arrow. You can also say cout hello, go to the new line and then display cout there. All of these statements, they do the same thing. They display hello there. We can go to the new line using end L. When you say cout double left arrow hello there end L, that end L indicates end of the line. You can also use \n. You can say cout hello there in double quotations \n. This \n means end of the line. It goes to the new line. We have these escape sequence characters, which each one they do something. Like \n will go to the new line. It causes the cursor to go to the next line for subsequent printing. \t causes the cursor to skip over the next tab. \a will make your computer to make a noise, which is an alarm. It will beep. \b is a backspace. It causes the cursor to back up or move left one position. \r is the return. It causes the cursor to go to the beginning of the current line, not the next line. If you put \, that will display a \. Single quotation will display a single quotation. \/ double quotation will display a double quotation. These escape sequence characters, they have to be enclosed in double quotations. Don't confuse backslash and slash. Remember, you put backslash in double quotation marks. When you want to include a library, you can say hashtag include iostream. There is no semicolon after the closing bracket. It inserts the content of another file into a program. It is a preprocessor directive. It's not part of the C++ language. It's not seen by compiler. The variable is used to refer to a location in memory where a value can be stored. With variables, you can store different data in your computer's memory. We use an assignment statement to store a value inside a variable. We call it variable because it can vary, it can change. You must define the variable, indicate the name and the type of the value that it can hold before you can use it to store a value. So in this example here, we're defining a variable named h. When I say int h, I'm defining a variable named h. H equal to 17, we'll put the number 17 inside h. Cout double left arrow h will display 17. If I say h equal to 18, h becomes 18. Cout h will display 18. We say if a new value is stored in a variable, it replaces the previous value. When you change the value of a variable, it will change from 17 to 18 in this example. The previous value is overwritten and can no longer be retrieved. The value that is being stored there, it will overwrite the previous value, and the other one is lost. We use the assignment operator to put something inside the variable. It has a single variable on the left side and a value on the right side. It copies the value on the right side into the location in memory that is associated with the variable on the left. When you say item equal to 12, 12 goes inside item. We say a literal is a piece of data that is written directly in the source code of a program. So we can have character literals like A, we can have a string literal like hello, integer literal like 12. Literal means like different constants that you use in your program. Like 12 is a string literal, 3.14 is a floating point literal. Identifiers are programmer chosen names to represent parts of a program, such as variables. Name should indicate the use of identifier. You cannot use C++ keywords as identifiers. They must begin with alphabetic character or underline, followed by any number of alphabetic, numeric, or underline characters. Alphabetic characters may be upper or lowercase. When you want to define a variable, you need to follow these rules. They have to begin with alphabetic, underline, followed by any number of alphabetic, numeric, or underline characters. You could have multi-word variable names. We say a variable name should reflect its purpose. Descriptive variable names may include multiple words. When you want to name a variable, you need to give it a name that it makes sense. Like if you want to name a person, you can say name. If it's last name, you can name it last name. We can capitalize all words, but the first letter of the first word. We can run words together, like for example, quantity on order, total sales. We can use underscore characters as spaces, like quantity on order or total underline sales. We use one convention consistently to a program. We have different conventions. Whenever you choose a convention, be consistent. So for example, in this example here, you see this Q is small, this O is capital, the other O for the order is capital. If you create a variable like this, be consistent. Always do the same thing, like total sales. If you're separating them with underline, be consistent. Always separate them with underlines. These are some examples of valid and not valid identifiers. Like total sales is valid. Total underline sales is valid. Total dot sales is not valid because it cannot contain period. Fourth, QTR sales is not valid because it could not begin with digit. Total dollar sales is not valid. It cannot contain dollar. So when you name a variable, it could be like total sales. It can be like total underlying sales. It couldn't have a dot. It couldn't start with a number. It couldn't contain a dollar. We have different data types in C++. One of them is integer. It's designed to hold whole non-decimal numbers. It can be signed or unsigned, like 12 minus 6 or plus 3. If it could be negative, we can create a signed variable. If it could be positive, if it's always positive, we use unsigned. If it could be negative or positive, we use signed. We have different variable sizes like short int, long int, and long int. Long int was introduced in C++ 11. These variables have different sizes. The smallest size is for short int, then int, long int. The longest size is long int. C++ allocates 1 bit for the sign of the number. The rest of the bits are the data. We have the first bit in the memory is the sign bit, which indicates if that number is negative or positive. If your program will never need negative numbers, you can declare variables to be unsigned. All bits in unsigned number are used for data. We say a variable is signed unless the unsigned keyword is used at variable definition. Some examples of defining variables can be like int length. If you want to define a variable that is integer, you put int. Int width means I have a variable width, which is an integer. You could define the variables in the same statement. For example, int length, comma, width, semicolon. Variables of different types must be defined in separate statements. If you have variables of the same type, you can define them in the same statement. If you have variables of different types, then you need to separate them into different statements. We can say int can be omitted from a variable definition for any data type except an int itself. For example, short temperatures, unsigned short books on order, unsigned long magnitude, int grades. These are all integer variables. We have different sizes for integer variables. Like the short is the smallest one. We can have unsigned short or unsigned long or integer variable. To store an integer literal in the memory, long memory location, we put capital N, L at the end of the number. For example, we can say long rooms equal to 234 capital L. We use LL at the end to put an integer literal in long memory. Literals that begin with 0 or octal or base 8, for example, 075. Literals that begin with 0x are hexadecimal or base 16. To store the floating point data types, we have different variables like float or double and long double. It's designed to hold real numbers like 12.45 or minus 3.8. They are stored in a form similar to scientific notations. Numbers are all signed. They're available in different sizes like float, double, and long double. Size of float is smaller than size of double, and size of double is smaller than size of long double. Floating point literals can be represented in decimal notation like 31.4159 or 0.000625. We could represent them using E notation like 3.14159E1 or 6.25e to the power of minus 5. By default, they are double. They can be forced to be float. For example, 3.14159F or 0.000625L. If a floating point value is assigned to an integer variable, the fractional part will be truncated. It will get chopped off. If you say int rainfall equal to 3.88, if you say cout rainfall, it will display 3. The decimal part will get cut off because the integer variable couldn't store the floating part. The character data types is used to hold single characters or very small integer values. It occupies 1 byte of memory. We say a numeric code representing the character is stored in memory. If you say char letter equal to C, this letter is a character which takes 1 byte. You're putting the single C characters inside that memory location. The ASCII code for that character will get stored in memory. You could display a character literal. A character literal is a single character. When referenced in a program, it is enclosed in a single quotation mark. For example, you can say cout double left arrow y in single quotation. The quotation marks are not part of the literal and they are not displayed. This cout statement will display a single y. We can have string literals. They can be stored as a series of characters in consecutive memory locations. For example, hello. They are stored in consecutive memory locations with null terminator placed at the end. For example, hello /0, it has the null terminator. Whenever you store a string in memory, the null terminator will get stored after the last character in the string. We say that strings are a series of characters. It means when you store a string in memory, you're storing several characters in the memory. When you want to store a string in memory, it's compromised of characters between double quotation. So a character literal is a single character enclosed in single quotes. For example, single quotation, capital C, single quotation. We say a string literal is a sequence of characters enclosed in double quotes. For example, double quotations, hello there. A single character in double quotes is a string literal, not a character. If you define a variable like C, if you put double quotations around it, that would be a string. It's not a character anymore. We have a library in C++, which is the string library. You must include hashtag include string to create and use string objects. You can define string variables in programs like string name. You can assign values to string variables with the assignment operator. You can say name equal to George in double quotation. You can display them by cout. For example, you can say cout double left arrow, my name is name. This string library has many functions inside it, which you can use, and you can apply them on the strings. We have another data type, which is bool. It represents values that are true or false. Bool values are stored as integers. False is represented by 0, true is by 1. If you say bool all done equal to true, you're creating a variable named all done, and you're putting true inside. If you say bool all finished equal to false, you're defining a variable named finished, and you're putting false inside. When you put true in a variable, the computer memory will have 1. When you put false inside the variable, the computer will store 0. You could determine the size of a data type. The size of operator gives the size in number of bytes of any data type or variable. If you say double amount, you're defining a variable named amount, which is a double. It's a decimal variable. If you say cout a float is stored in size of float bytes, this size of will display the size of the variable float. If you say cout variable amount is stored in size of amount, this size of will display what is the size of this variable amount. So the float is 8 bytes. With this size of function, you can see how many bytes of memory this variable takes. You can assign a value to a variable. For example, you can say int size equal to 5 plus 2. This is legal. You couldn't say 5 equal to size because when you use this equal, the right-hand side goes to the left-hand side. 5 plus 2 goes inside size. You couldn't put a variable inside the constant. You could put the resultant expression inside the variable. There is a difference between variable assignment and initialization. Initialization of variable means when you give an initial value to a variable. At time it's defined. If you say int length equal to 12, you're defining a variable named length, which is integer. You're assigning it with value 12. If you say int width equal to 7, comma height equal to 5, comma area, you're defining three different variables and then you're initializing them with 7 and 5. You could use auto in variable declarations. If you're initializing a variable when it's defined, we use auto keywords that will determine the data type to use based on the initialization value. This auto was introduced in C++11, which is the new C++. For example, you can say auto length equal to 12. Length is an integer because this 12 is an integer. If you say auto width equal to length, length is an integer, width becomes integer. If you say auto area equal to 100.0, since 100.0 is a decimal number, area becomes a double. We say the scope of a variable is the part of a program where the variable may be used. In this example, when you say int num1 equal to 5, the scope of the num1 is from the definition to the end of this program. You could say cout num1, that's legal. You couldn't say cout num2, that's illegal. If you say int num2 equal to 12, the scope of num2 is from the definition to the end of the program. The scope of the program is where that variable is visible, when you can use it. We have some arithmetic operators. We have some operators that take one operand like negation, like -5. We have some operators that they take two operands, like 13 minus 7. We have some operators that they take three operands, like expression 1, question mark, expression 2, semicolon, expression 3. So in C++, we have different kinds of variables. They're used for performing numeric calculations. In this examples here, we say adds equal to 7 plus 3. This is addition. If you want to add two different variables, you can use plus. In the other example, we have adds equal to 7 minus 3, which is 4. That is subtraction. If you say adds equal to 7 times 3, that is 21. That's multiplication. If you say adds equal to 7 divided by 3, it gives you 2. That is division. If you say adds equal to 7 modulus 3, the remainder of dividing 7 by 3 is 1, which is modulus. These are the binary arithmetic operators in C++, which you can use. In C++, with this operator, you can divide. For example, you can say cout 13 divided by 5, which displays 2. If you say cout 2 divided by 4, it displays 0. C++ division operator performs integer division if both operands are integers. If either operand is floating point, the result is floating point. For example, cout double left arrow 13 divided by 5.0. It will display 2.6. Cout double left arrow 2.0 divided by 4. It will display 0.5. So when you use the division, if you divide integer by integer, that division is integer division. If you divide integer by floating point, that division is floating point division. The C++ modulus operator computes the remainder resulting from integer division. For example, you can say cout 9 modulus 2. This displays 1. The modulus operator requires integer for both operands. If you say cout 9 modulus 2.0, you will get an error. You couldn't have a decimal point number here because the modulus operator takes an integer data type. The comments are used to document parts of a program. They are written for persons reading the source code of the program. They indicate the purpose of the program. They describe the use of variables. They explain complex sections of code. They are ignored by the compiler. Comments are not part of the program. They're just some note there. When you want to write a program, it's a very good practice to put comments. The comments, they don't get compiled. They're not part of the program. They're just some comment there. If you want to write a single line comment, you can put // int length equal to 12. You're defining your variable length. You're initializing it with 12. Int width equal to 15. You're defining a variable width. You're initializing it with 15. Int area is the area variable, which is integer. If I say area equal to length times width, I can calculate the rectangle area using multiplication. You could have multi-line comments in C++. They begin with /* and */. They can span multiple lines. For example, /*. This is a multi-line comment, */. They can be used as single-line comments like int area. The programming style refers to the visual arrangement of the source code. So when you want to write a program, you can have a programming style. It means how you write your program. You can put some alignment. You can use it consistent through the program. It's a very good practice when you write your program. Write it organized. Make sure that whenever you open a brace, you close the brace. To put some comments to make your code more readable.